Hello, geometry students. This is Mrs. Graney coming to you from my living room. I hope everybody's doing great. I miss seeing all of you. I'm excited to be able to teach you still using this platform. So I hope you're ready to learn. We have some good stuff to study. So what we're going to be working in today is our volume packet. And I gave this packet to most of you before we left. So if you did not get it, what you need to do is either go print it out right now. I've attached it to Google Classroom, or you can just do this work on a piece of paper. Just make sure it's neat so I can make out what you're doing and following your work. So without further ado, let's start our lesson. So what we're going to be studying in this packet is the volume of different three-dimensional figures. And the first three-dimensional figure that we're going to talk about is the prism. Now, a prism has two parallel and congruent bases. So if you look at the triangular prism, these two triangles are congruent and parallel. If you look at the hexagonal prism, these two hexagons are congruent and parallel. So those are the bases. When we look at the rectangular prism, honestly, either the left and the right could be our base. The front and the back, this is going to look like a mess in a second, but the front and the back could be our bases, or the top and the bottom could be our bases. And that's just a special case. So here's the bottom and here's the top, because those are all congruent and parallel. So what we're going to talk about right now is how to find the volume of a prism when you've been given the area of the base, which is represented by capital B, area of the base, and the height. Okay, so area of the base and the height. And the formula is very simple to follow. Just volume equals area of the base times the height. Okay, pretty simple formula. So we're going to go ahead and do the second one together. So we're asked to find the volume of the prism. So volume equals area of the base times the height. We have been given the area of the base to be 100 inches squared and the height to be 6 inches squared, which means the volume is 600 inches cubed. The reason that it's inches cubed is because this is a three-dimensional measurement. It's how much space fits inside the prism. Okay, so you're going to do number one a little bit later. We're going to turn the page and we're going to look at, we love these reverse solve problems. So we're using the very same formula, but if you notice on these problems, we're going to give you the volume of the prism and one of the other dimensions, one of the other measurements. So either the area of the base or the height. And as usual, you write your formula, substitute your values into the appropriate place, and then solve for the variable that we don't have. So we do not know what the height is. We can simply divide by 20 on each side, and we find out in this particular problem that the height is 25 meters. So let's go ahead and do number two on the back. It says find the volume of the prism whose base is a 45, 45, 90 triangle. Okay, and the legs are 5 feet. So I just want to kind of think about what this base is, because we're going to have to think about what shape the base is and what the base formula is. So in this case, we have a triangle. Our initial formula starts out as volume equals area of the base times height. But I like to call this area of the base, this capital B, a chameleon, because that is going to change depending upon what shape we have. Now, the base of our prism is a triangle, and we know the area of a triangle is base times height divided by 2. So we're actually going to replace the capital B with base times height divided by 2, and all of that relates to the triangular base that we've been given. And then the height represents the distance between the two bases. In other words, where it says right here, the height of the prism is 12 feet. That is this height right here. And it's kind of confusing because we're using height twice. But let's go ahead and do this. We're going to say volume equals, and now we're not really looking at this formula. The base and the height of the triangle are 5 and 5, and the area of a triangle calls for us to divide by 2. And then the height of the prism is 12. In other words, that's the distance between the two bases of the prism. So now we're going to go ahead and just stick this in our calculator, and we should get that the volume of this prism is 150 feet cubed. And again, it is a triangular prism, so that's why we had to use base times height divided by 2 in our formula. Okay, let's take a look at number 4. So number 4 is an interesting case because this one, we're not really being told what the base is. But remember on the previous page, I told you any of the sides, any pair of opposite sides could be the base. So I'm going to call the bottom and the top the base. Okay, so the bottom and the top the base. So again, we start out as we always do. We write our formula. But remember that B, we're going to replace that. The shape of our base is a rectangle. And we know to find the area of a rectangle, we do base times height of that rectangle times the height, in other words, the distance between the two bases. So base and height refer solely to this rectangle right here. So we're going to get volume equals 6 times 4. And then the height is the distance between the two bases, which is 5. When we multiply all of these numbers together, we get 24 times 5, which is 120 centimeters cubed. And that is the volume of this prism. What I need for you to do for homework is to finish the problems that we skipped. Okay, I know you can do it. Good luck. Have fun.